let us put the values of u1 and u2 in these two equations, and therefore let us get by using first condition from these two equations. And therefore what we do, I put x is equal to 0 here because here x is 0, and then value of u1 will be, I will get u1, let us u1 will give me a, because it will be 0, so let me write it directly, that is a plus b, because here also x is 0, this e0 is 1, so we get b only, equal to, so this is the value of u1 at 0. Now u2 at 0 means this u2, when I will put x0 I will get only c, plus when you put here x is equal to 0 you will get only d. So that is the equation we get from by using first condition in equation number 10 and 11. So let us name it at 12. Now second equation, I have to put a firstly in u1, then I will get a e iota alpha minus k into this thing. X means I have to put now a, this a, plus b e minus iota alpha plus k. Here x I have to put a because in u1 I have to put a, and in u2 I have to put minus b. Therefore this term will give me c e beta e iota k. Here x mean I have to put minus b, so b here and minus here, then plus d times e, here beta minus beta plus iota k I have to put this one. Now here minus b here, and this minus will become plus this one, so I will get plus here. So this is the value of these two equations by putting this condition. Let us have this equation as 13. Now 14th equation we will get from by putting this value. So for this I have to differentiate firstly this, and then I will put the value of 0. Differentiation of this will give me iota alpha k multiplied by this term. Therefore I will get iota alpha minus k times a. Here when I will put x0, then this term will be 1, so plus. Now here in this case I have differentiation, I have to differentiate, so I will get minus iota alpha plus k. So let us write here minus term minus iota into alpha plus k times b. You put here 0, so it becomes e0 1, so I will get only b here. Now u2, this term is u2, I have to differentiate it. Again here I will get beta times minus iota k into c, as I have to put 0, it will become e0 1, plus here I have now x is 0, but this factor will come here on differentiation. So let me write here again negative. So because this minus beta will come here, beta times beta plus iota k, this multiply by d. So this is equation number 14. We are getting these equations from 10 and 11 by putting these conditions. Now last condition is I have to differentiate these two terms, and I have to put in u1 I will put a here, and in u2 I will put minus b. So naturally what we get is here this kind of term on differentiation, this term, but I will get the same term, but only thing is I have to put a here. So I will get minus or iota alpha minus k a e times Here I have to put A in this case. So iota alpha minus K times A plus, now here this on differentiation this term will be same, so I have to use here negative sign because this negative will make it a negative. Iota alpha plus K E iota alpha plus K times A equal to, right hand side will be u2 term, so differentiating this and differentiation will be almost this. I have to multiply these terms, therefore we get here C times, sorry, this B times beta times beta minus iota K C E, from here beta minus iota K, and I have to put here minus B because it is at minus B, so B, and here I will get minus term. Then next term is this one, that is plus, so let us put this value here in differentiation, this term, that is minus beta plus iota K, beta plus iota K here, multiply by dE. Now this term minus beta plus iota K, but I have to put minus B, therefore B, it becomes plus. So this is our equation number 15. So it shows that we have got these two solutions of the equations, differential equations, and using the boundary conditions we have got 4 simultaneous equations. Now these four equations can be solved for non-zero values of a, b, and c, d only if the determinant of the coefficients of a, b, c, d here becomes 0. That means we have to write a determinant by using coefficients of a, b, c, d in all the 4 equations, and then we will put this determinant equal to 0, and then we can solve these simultaneous equations. So let us write down determinant by using the coefficients of a, b, c, d in these 4 equations. So in first equation we will write the coefficients of a, b, c, d, so that is 1, 1, 1 only. So the coefficient of this, let us say the coefficient of a is 1, coefficient of b is 1, coefficient of c is also 1, coefficient of d is also 1. So then coefficient of a, b, c, d in 13th equation, that is we can write e iota alpha minus k times a, this coefficient. Then coefficient of b e minus iota alpha plus k a, this coefficient. Then coefficient of c means e minus beta minus iota k times b, this is the coefficient of c. And coefficient of d is this one, that is e raised to the power beta plus iota k times b. So this is the coefficient of d here. Now in 14th equation, coefficients of a, b, c, d, we will write iota times alpha minus k. Here coefficient of b is minus iota times alpha plus k. Coefficient here of c, that is beta minus iota k, this thing. Now coefficient of d here is minus beta plus iota k. Now let us write coefficients of a, b, c, d in equation 15. Here I will get iota times alpha minus k e iota alpha minus k a. I have not to write a, but remaining things I have written here. Then coefficients of b here. Sorry, I have to put here b also, I forget that. So coefficient of b will be equal to minus iota alpha plus k from here. E iota alpha plus K times A. So therefore we get coefficients of B. Now coefficient of C I have to write. For that I will write beta minus iota K, this one, E minus beta minus iota K times B. Now coefficient of D, that is minus beta plus iota K E into B plus iota K e raised to power beta plus iota K times B. So these are the coefficients of ABCD in all the four equations, and we make its determinant form. And to solve these equations, this determinant should come out to be 0. Now we have to expand this determinant, but the expansion of this determinant is very tedious, and therefore it is out of the this is not in the scope of this course to expand it. Therefore what we do is we just write that on expansion of this determinant we get result of the nature beta square minus alpha square divided by 2 alpha beta times sine hyperbolic function of beta b and sinusoidal function sine of alpha a plus cosine hyperbolic function of beta b and cosine function of alpha a must be equal to cosine k times a plus b. So this is the solution what we get from expansion of this determinant, and let us write it as equation number 16. So how do we get this equation? It is by the expansion, by expanding above determinant, this determinant I have to write determinant, we get this equation like this. Now to solve this equation further, or to get more convenient form of the result, Kronig-Penney used the conditions that when V naught, that means this potential V naught, tends to, let us say, very large value, or let us say infinity, when V naught approaches to infinity and B, that is the thickness of barrier, that approaches to 0. Okay, so means V naught will tend to infinity and B tends to 0. That is the condition, but restriction is that V naught and B will be finite. You see, otherwise mathematically if it is infinite and you multiply by B, then it is undefined term, but we'll say that it is a finite term, and this property may be considered as Dirac delta function, and the potential barrier just becomes like a Dirac delta function. That means like this, at this point it becomes infinite, but the whole value in this range, that will be finite. And using this condition along with another condition, that is as B approaches to 0, then sine hyperbolic function which we have taken, beta b, that approaches to only beta b, and cosine hyperbolic function of beta b, that approaches to only one value. So that is very important value here, that b, we have taken here b approaches to 0, and when b approaches 0 here, then sine hyperbolic beta b will be beta b only, and then cosine hyperbolic beta b will be equal to 1. So these are the important results. If we use these results in our equation number 16, then equation 16 can be written as equation 16 becomes, because we have to put the values here, these values, so we get beta square minus alpha square over 2 alpha beta. It will become simply approximately equal to beta square over 2 alpha beta, and which you can write simply 1 beta cancels here, so we get beta over 2 alpha. And if we put this value here in this case, then equation 16 becomes beta square b over 2 alpha into sine alpha a plus cos of alpha a is equal to cos of ka. This cos of ka, because here b approaches to 0, so we get cos ka only, and this becomes 1, this becomes here 1, and this is beta b, and out of that beta b, this beta will cancel out, and this b will come here. So that is the equation we get from above approximation. Let us write this equation as 17, and to solve it further, what we take is, we just put one more, we just define one more quantity, that you can say that this beta square, if you multiply here by a, let us say, multiplying and divide by a, I multiply here a, I multiply here in the denominator. So from this equation we can write one new value, that is p is equal to this vector, that is beta square ab divided by this 2. So we define p is equal to this thing, and here beta is nothing but, in terms of v naught, we can write it as 2m over h cross square into, initially we had got, beta square, we have taken here that beta square is equal to v naught minus e, but because e is very small and v naught is now very large, as we are saying that v naught is approaching to infinity, therefore we can just neglect the value of e, so we can write only here v naught into this ab divided by 2. So ultimately what we get is mv naught over h cross square into ab. So this term we get from this part as we put p, and let us now write this equation or this equation, we can say, because we have simplified this term into this. So equation 17, again we can write equation 17 can be written now in terms of p, that p sine of alpha a divided by alpha a, this alpha a, plus cosine of alpha a is equal to cosine of ka. This is next equation number 18. Now to solve this equation number 18 is also very tedious and very complicated job, but we can analyze this equation graphically, and the method of analysis is that if we plot the graph of this left hand side term with respect to alpha a, because alpha a is variable here, so if we plot graph of this with respect to alpha a, then we can analyze this equation. And another thing we have to notice here, that is right hand side is cos ka, and this is cosine function, and the maximum value of cosine function may be plus minus 1. But it is right hand side of the whole equation. It means if its value is between minus 1 and plus 1, then the value of this function will also be between minus 1 and plus 1. So that means when we will draw the graph of this function, then the value of that graph will be only valid which is between minus 1 and plus 1. So these 2 points we have to keep in mind, and keeping these points, let us now try to draw a graph of this total value with respect to alpha A, and we get the graph like this. So this graph comes out to be this way. Here I have plotted this graph, this yellow line graph, and this is the graph of this term of left hand side, and which I have written here. And this graph is with respect to alpha A, which is the variable here, and we got this yellow line graph. Now you see that this graph is varying from this value to minimum value, again increasing like this. But on the right hand side we have cos term, which is varying between minus 1 to plus 1. So these pink lines are showing that the value of cos, that is right hand side, varies only from minus 1 to plus 1. It means the values of this yellow line curve are valid only which are lying between this plus 1 line and this minus 1 line. But outside these lines, that means this portion and this portion and this portion, similarly here this portion, this portion, this portion, these are not allowed values. So we can say that outside this pink line, these values which are shaded by red color, these are not allowed values. All these values are not allowed. And this is the major part, or this is the major portion we get by using Kronig-Penney model, that all the part of energy is not allowed. Only the portion of energy is allowed which is lying between plus 1 and minus 1 value. And these values, you can mark the value of alpha A as alpha A will have this intersection point, let us say this intersection point here. This is first intersection point by the pink line, and this is here. After that we can have upside, this is also intersection point here. So between this line and this line you can mark the value. If we say this value, this is equal to, you see, pi, this value we can write it as pi value here. The value of alpha A is pi at this point, and the value of alpha A is 2 pi at this point. This is 2 pi. And similarly here you can say the first intersection point is this one, and therefore this point is minus pi, and here this is second intersection point, and this is minus 2 pi. So this way the value of alpha A varies. And if we mark this, let us mark these values from this intersection point here up to this intersection point, this one. So we can say this part of the energy is allowed only, but because after that it is going outside, this part is not allowed. And similarly you can say the value of this yellow line or this function is lying between this point, because after that it is going outside. So on the x-axis or alpha A's axis, this value from here to here and this value from here to here, you can say this value is allowed. So value of this function along alpha a is allowed only along these two values. Similarly, next values you can mark from here to here. That means this value is also allowed. Reason being, after this value it is going outside, it is not allowed. After this point it is going outside, it is not allowed. Similarly, you can mark this side, that from here, this point, up to here, that is up to this point, only this value is allowed. So what we find is, in this graph, that all the values of this graph are not allowed, but only few values of the energies are allowed. And these allowed values may be taken as band energy or energy bands, and the energy outside of this value, that is from -1 to +1, these values are not allowed here, and these values are called forbidden values.